We're starting a new topic, elevation determination and leveling. By the end of this lesson, the student should be able to understand different terms used in leveling and use differential leveling process in determining elevation of 2 points. To start, let's define first what is differential leveling. Differential leveling is a surveying method we use to find the difference in elevation between two or more points. In other words, it tells us how much higher or lower one point is compared to another. Here's how it works in simple terms. We set up an instrument called a level or dumpy level on a tripod. As you can see here, the red circle indicates the location where the instrument is set up. Then we place a leveling stop or leveling rod on the point where we want to know the elevation. In this case, the first point is at point A. The instrument reads the rod and gives us a value. By moving the staff to another point at point B and taking another reading, we can calculate the difference in height between those 2 points. The difference between those readings tells you how much higher or lower the second point is. Why is this important? Because in engineering and construction, knowing elevation differences helps us design roads, canals, buildings, and drainage systems correctly. If we don't measure properly, water might not flow in the right direction, or foundations might end up uneven. Now that you know what differential leveling is, let's talk about the instruments we use to do it. There are three main tools: the dumpy level, the leveling rod, and the level vial. Let's start with the dumpy level. This is the main instrument we place on a tripod. It has a telescope that we look through to read measurements from the leveling rod. Its main job is to create a perfectly horizontal line of sight so that when we take a reading, we know it's accurate. Next is the leveling rod, sometimes called a level staff. This is a long graduated rod marked with measurements, usually in meters or feet. Then we have the level vial. This is a small glass tube filled with liquid and a bubble inside. It's attached to the dumpy level. When the bubble is centered, it tells us that the instrument is perfectly level. Without this, our measurements would be slanted and inaccurate. Then, when you look through the telescope of a surveying instrument like a dumpy level or total station, you don't just see the target. Inside the telescope, you'll notice two thin lines that intersect each other, one horizontal line and one vertical line. So this is called the crosshair. The purpose of the crosshair is to give us an exact reference point so we know where we are aiming. The vertical line helps us keep the instrument aimed straight at the rod or target, while the horizontal line is the one we actually use to read the measurement on the leveling rod. So whenever we take a reading, we look where the horizontal crosshair cuts across the leveling rod, and that's the value we record. Okay, class, before we start solving problems in differential leveling, we need to understand some important terms. These are benchmark, turning point, backside, and foresight. Let's begin with the benchmark or BM. A benchmark is a fixed reference point with a known elevation. It's usually a permanent mark like one carved on a concrete post, a building corner, or a monument. Surveyors use it as the starting point for leveling. Think of it as the anchor point that tells us this is our base height. In practical surveying, a benchmark is a point with a known elevation that we can trust when performing differential leveling. For our lesson today, we don't have the exact official benchmark data for Naga City, so surveying teams in the Philippines often rely on records from NAMRIA or local engineering departments to find that information. But to make things relatable, let's use the Naga City Hall as our example reference point. According to elevation data, it stands at about 11 meters above sea level. Alternatively, if your project is near the Naga City Sports Complex, which sits around 37 meters above sea level, you could use that as a reference. Later on, if you're working on a real surveying project in the field, remember that professionals always obtain benchmark locations and elevations from official sources like municipal offices or NAMRIA. Next, we have the turning point or TP. Sometimes, when we are leveling, we cannot cover the entire distance in one setup of the instrument. So we use a turning point. It's simply a temporary point underground where we place the leveling rod to transfer elevation from one setup to the next. In short, the turning point is like a stepping stone that helps us continue our measurement. So let's say, for example, imagine you are surveying this area. You set up your dumpy level in front of this building and take a backside reading from a benchmark there at point A, but the distance to point C is too far to see directly from that setup. So you place a leveling rod on a solid object like this point at TP1 between these 2 points. So this object becomes your turning point. After recording a foresight reading on that turning point, you move the instrument closer to point C. Then you take a new backside from new instrument setup on the same turning point. This way, the turning point acts like a bridge for transferring elevation from one instrument position to the next. Then, now let's move on to the backside or BS. The backside is the very first reading we take from the instrument. It is always taken on a point of known elevation, usually the benchmark or a turning point. The purpose of the box sight is to help us calculate the height of instrument. You can imagine it as the surveyor looking back to where the height is already known. Finally, we have the foresight or FS. So this is the last reading taken before we move the instrument. It's placed on a point of unknown elevation, like a turning point or the final station we want to measure. The foresight allows us to determine the elevation of the new point. You can think of it as the surveyor looking forward to find the height of the next location. So this is the illustration of the instrument setup where you're getting the backside and the foresight reading. So to summarize, benchmark is a reference point of known elevation. Turning point is our temporary stepping stone when we move the instrument. Backsight is the first reading on a known point, while foresight is the last reading on a new point.